So, okay, good afternoon, students. Am I audible clearly? Good afternoon, students. Am I audible clearly? Okay, before ISC, we started with the fourth chapter, that is machine learning. So this is the syllabus which we are going to study in this chapter. So already few of the points we have covered, only last point is remaining. So initially we have seen overview of machine learning concepts where we have seen what is meant by overfitting and train and test splits. So overfitting, it means that whenever we are having before that, let us see what is meant by training and test splits. So training splits or test split, let us say training splits, or I can say the training data. These are the data on which already labels are there. For example, if I wanted to find out any object, or if I wanted to classify into some of the or categorize into given objects into category, etc. So in that case, training, it means that here already the labels are available, that is along with the data we will also have labels to that data, and based on that data we design a model, or we design a formula which will specifically find out some feature, just like what your label is there. For example, class of given that is out of multiple classes, to which one the object belongs, or if I'm going for object recognition, etc., in that case which object is that. So it means that in the training data we work on the data and expected that whatever the class label or label is there to my data, the same label we get as a output. So based on that we design a model. And test split, it means that here whatever the data we are passing or giving as input, they don't have the output label. So here overfitting, it means that there are three concepts we have learned: generalization, overfitting, and underfitting. So generalization, it means that the way model works in the training data, in the test data also it gives me the same kind of output. It means my model works correctly. Whereas in case of underfitting, whatever model I'm designing, that is not going to work, or that doesn't give the specified output with the trained data. And hence that model is called as a underfitting. And in case of overfitting, the model works well with the trained data, but as soon as it works with the test data, it shows the curve split. Curve split, it means that whatever the data or expected output is there, we are not getting that output. So these concepts we have learned into this first point. Next, we started with the types of machine learning, that is supervised, unsupervised, and reinforced learning. So supervised, where we have already have a label data, train and test data, and based on that we decide. So supervised learning, it means that we supervise the model whether it works with the trained data, and if so, then we apply it to the test data. In case of unsupervised learning, we don't have any label data. Always all data is unlabeled, and because of which we are having much more freedom to use the required parameters. And hence, that's why unsupervised learning is there. And in reinforced learning, we are having trial and error, that is try and error methods, where we learn by trying multiple models whether this works or not. Okay, so here each method of this machine learning is having its own advantages and disadvantages, so it depends on which application we wanted to use. Next, we studied about the Bayes theorem. So Bayes theorem, this is a theorem which is based on the conditional probability. Conditional probability, it means that here whenever we are talking about two events, event 1 and event 2, consider. So here, if consider event 2 has already happened, okay, and I wanted to check what is effect of event 2 on happening of event 1, or in which way the event 1 contributes to the event 2. Okay, it means that here one event has already happened, and what it can have the effect on the second event. So condition, it means that if first event occurred, then what is chances of having the second event? or if the first event is not occurring, then what is the chances of the second event? So here, this conditional probability condition we have seen. So Bayes theorem involves the formula that is regarding the conditional probability. And this is one of the most widely used concept into the machine learning. So if you're having doubt in any of the first 3 points, let me know. Else we'll go for the last point in the syllabus, that is a fourth chapter syllabus, that is linear regression. So okay, now let us start with the linear regression model, assumptions, regularization, that is regularization, lasso, reach, and elastic net. So these are the three variations of the linear regression are there. So before moving to the linear regression, let us see what is meant by linear regression. Okay, so we wanted to talk about this first. So linear regression, it means that we are using linear model. Okay, so before that, let us see what is meant by a model. So this word frequently we have learned into this method in this chapter. Model, it means that this is the mathematical relation. Okay, mathematical relation which shows the relationship between the attributes or data values. For example, if I'm saying y equal to ax plus c, okay, so this is my formula. So we know that here, after increasing, if consider I'm having a equal to 4, okay, a positive value is there, and c equal to consider any constant as a 7. Okay, so here I can say that as my x is increasing, okay, as my x is increasing, y will also increase. Okay, it means that if consider I'm having x equal to 0, then I can say that y equal to 4x, 4 multiplied by 0, that is 0, and plus 7. So I will have y equal to 7. So the next, if I'm having x equal to 1, then y will have its own value. So if I'm having x equal to 1, y equal to 4 plus 7, 11 will be there. So it means that here, this feature, how this feature is contributing to compute to the another feature y. Okay, so whenever we are talking about the model, so model, it means that this is a mathematical relations between the features values. So x, I guess that this is one of the feature which will be able to predict the value of y. Okay, so y, this can be another feature, output class, that is in which class the object can fall, etc. It means that y is my expected output, and this is my relation, or this are the set of attributes, or consider that these are the variables which will help me to calculate the output y. So here, this, whatever this equation is there, so this is a very first or simplest form of the machine learning, we can say. So here, this is called as a linear model. Linear model, it means that only the single form of x is used. Yes, I can have many features, like I can have a1, the first coefficient and first feature. I can have another coefficient and another feature. Okay, plus I can have many features, that is for a single object or single data. I don't have only single data, I can have data in multiple ways. So I can say that I can have any coefficient as a3 and x3 as my feature. Similarly, I can have n features within my data, and similarly such an plus xn can be there into my data. Sorry. So again, here I can say that only the linear form of each of the feature is used. It is not just like a square or square root, etc. is used. Only a simple original form of the same feature we are learning, we are using here, and that's why This type of model is called as a linear model. Okay, and hence whatever this computation function is there, that is also called as a in linear function. That is a function to calculate a value y. So linear model makes a prediction using linear function of the input features. So here, whatever this x1, x2, x3 are there up to xn, these are my input features. Input features, that is, for example, if I'm talking about a book, I can have x1 equal to price. Okay. Then I can have x2 equal to number of pages, number of pages, etc. It means any value. Then length, width, height, sorry, the three parameters, weight. Again, I can have number of authors, etc. It means anyway I can preserve the data of my book. So these will be called as the features of my book. So x1 will be my one feature, x2 will be my another feature. And it is when we are designing a mathematical formula, so we are expecting that it should have a numerical value, but at all this is not mandatory. Okay, this is not mandatory because here we can have just like author, etc. So author, this is my alphabetical value. Even this is one of the features, I may not use that into the relation. Okay, right now we expect that right now whatever my features are there, these are numeric in nature, and that's why I have designed a mathematical relation. But it is not always mandatory to have the all the features to be numeric. We can have alphabetical features as well. Okay, so but here right now we are talking about the model, which is a mathematical function. That's why we are dealing with only the digital, or sorry, numerical values. Okay, so whatever this equation is there, this is exactly you might have studied about the planes, uh, points, and line, etc. So this is a very similar to the slope of slope, or we can say the linear uh, equation for the line. Okay, where a is my slope, x is my x value, and c is my constant, and I'm predicting what can be the value of y. Okay, and that's why this function, this type of the function is called as a linear model. So linear model, this is the simplest way of prediction, and always machine learning concepts, that is whenever we design the algorithms or model building, etc., it always starts with the linear regression, or we can say a linear model. Clear with this? So what is meant by linear model actually? So linear models are a class of models that are widely used in practice, that have been studied extensively in the last few decades with roots going over 100 years. So linear models can make a prediction using linear functions of the input features. So here we wanted to make a prediction, and for this purpose we are using a linear model, and prediction is regarding a linear function of my input features. So for regression, so this is the same formula right now which I have explained, that is x0, x0, x1 up to xp, these are the features, be it some constant value, and w0, w1, these are the coefficients, and x0, x1, these will be called as the attributes. Okay, so for regression we use this linear model. So x0 to xp denote the features. In this example, the number of features is p of a single data point. Okay, right now whatever this complete collection is there, we are talking about a single data member. For example, if I'm talking about the book in previous example, okay, here if I'm talking about the book, I will be talking about the database book, then I will be talking about the data science book. Okay, it means that this is my single data and this is my single data. I will have different features for this book and I will have different features for this book. So W and B are the parameters of model that are learned, and Y is a prediction that model makes. So for data set with single feature, so this can be a formula. Whenever I'm having only one feature, then feature count starts with the 0. So up to uh, that is, we can have this equation at the last. So here, these are the W and B are the parameters to be learned. So the meaning is that initially I don't know what can be the value of this W0, what can be the value of this W1. So for example, I will be given just like this value, say, that is, so I will be given initially value set like that is, in case of supervised learning, we are talking about y equal to 4 is there, and c equal to 7 is there, then and x equal to 0 is there, or x equal to consider um, x equal to consider I'm having 5. Okay, so this is the value. So in that case, I can calculate a here. Okay, if here initially the set is that I'm having y value and I'm having x value, that is output of label also I know, and the feature value also I'm having. So it means that here at this point, we need to calculate what can be the value of A and C. ओके, क्लिअर अप टू दिस? म्हणजे कळालं का की नक्की मला स्टडी काय करायचं ते? माझ्याकडे एक्स ची व्हॅल्यू आहे, म्हणजे माझ्या फीचर्सची व्हॅल्यू आहे. फॉर एक्झाम्पल डेटाबेसची प्राइस, डेटाबेसच्या बुकची प्राइस कन्सिडर आय एम टॉकिंग अबाउट 600. ओके, and why consider that this is taken into no, I will not take this example. Okay, I will take another example. Okay, I'm having length. No, I cannot take any real life example. Length. Okay, what I will do, I will having consider that I am having database of 4 to 5 flowers, and out of that, red color it's shown by some value. Okay, consider RGB value. So RGB I'm having FF0, FF, that is for the red, 00 RGB. Okay, so this is the value for the red. So it means that right now I'm having X as this value. This is one of the features I can say, or we can take this into the numerics also. And then why I know that this flower is hibiscus. Okay, it means that for the hibiscus showing, I will take a class number just like 2. Okay, consider that here I'm having data of 5 flowers. Okay, 5 flowers picky. First consider I'm having mogra, second one I'm having consider hibiscus, third one consider I'm having lily, etc. It means that these are the different types of the flowers I wanted to say. I will take rose, and I will consider which another flower we should use. Okay, can anyone suggest? Okay, orchid I will take. So here, if consider I'm having these kinds of the flowers. If consider the color is red, then I can say that the flower is definitely a hibiscus. It means that I'm having this X value and I can predict the Y value. Similarly, this is a one combination of the values. If consider I'm having X value, equal to white, consider that all the values are 0, and y equal to, consider the Mogra is the first, so then I can say that this is a 1. Okay, if consider in the equation I am having 4 attributes or 4 values or 4 parameters, y, a, x and c, and out of that 2 are given and 2 are unknown, a and c are unknown, then 2 values are sufficient to find me the value of a and c. Okay, so it means that here I can find out by putting the value of x equal to 0. I wanted to say that y equal to 1 is there, so it means that x multiplied, that is 0 multiplied with a, I will get 0, and y equal to 1, it means that c is equal to 1. So here I calculated the value equal to 1, and then I wanted to calculate the value of a, so then I will put c equal to 1 into the equation and then we'll calculate the value of a. So c equal to 1 and x equal to, consider this is some other value, just like for the colors etc, I'm using some numeric like 5, 10 etc, consider, then in that case I can calculate the value of a. So it means here I also calculate the value of a. So here the linear model says that we need to calculate w and b here. So b is nothing but my c, and w is nothing but my a. But when it comes to the linear model, I cannot guarantee that we are studying only one feature or one parameter, etc. Here, multiple features are there and multiple coefficients will be there. And that's why here we need multiple data samples, and so that we can study what can be the exact value of these coefficients. Okay, W0 ची value काय, W1 ची काय, WB P ची काय. So here finding, that is passing the different values of the characters, different values of the attributes, and then finding the values of WB, W0, W1 or these coefficient. This is called as a model training. Model training, already I know what is output and I am having some of the inputs, and based on that we will calculate what can be the values of these all. And that's why this will be called as a model building, and we can say that we are learning parameters. लर्निंग म्हणजे काय की याच्या व्हॅल्यूज काय असू शकतात ते आपण लर्न केलं by using the existing set. Okay, clear with this? Please take a look at the slide, read it thoroughly, and then we will go for the next point. Okay, here is an example that is how we can learn for the data. Okay, so model, it means that here I'm drawing this line, and within that, if consider my training data is giving somewhere else data members. So here main purpose is that whenever I'm designing a model, maximum points, that is maximum data points, should be covered within this line, or all those points should be nearer to the line. That is actually the model, linear model is proposed. So linear model, it means that whatever the model, the line is given by the model, all my data points should lie within the same range of my line. म्हणजे मॉडेल डिझाईन करण्यामागचं पर्पज काय आहे की माझे डेटा पॉइंट्स याच्या आजूबाजूलाच कुठेतरी असायला पाहिजे, जास्त डिफरन्स नसायला हवा. It means that I'm predicting this value. It means that my data will lie somewhere near this. That is, this is a prediction and this is a training data. Training data म्हणजे असं नाही की तो एका फ्लो मध्येच येईल. No, here whenever we are designing a linear model ही एक स्ट्रेट लाईन आहे. म्हणजे लिनियर म्हणजे एक स्ट्रेट लाईन मला ते आउटपुट देतं, पण माझा सगळ्याचा सगळा डेटा प्रत्येक फीचर नुसारच असेल असं नाही. माझा डेटा प्रत्येक फीचरवर चेंज होऊ शकतो, अँड बिकॉज ऑफ विच आय विल नॉट गेट ऑल द डेटा पॉइंट्स इन टू अ सिंगल लाईन. बट द मेन पर्पज इज दॅट I should have the maximum coverage of my data points nearer to my line. Okay, let me show you a figure. Okay, initially directly going to this, let me show you the figure. Okay, initially, whenever I'm designing my model, before creating a formula, त्याच्या आधी मी काय करेन की माझे जेवढे जेवढे डेटा सॅम्पल आहेत ते सगळे ड्रॉ करून घेईन. ड्रॉ करून घेईन म्हणजे काय की माझ्याकडे एक्स व्हॅल्यू आहे and I have y value as well. So based on this, what can be the input of my x and what is the appropriate value of y? Based on that, I will draw my graph, or we can say the plot of points. And later, okay, याच्यानंतर मी काय करेन, एक पॉइंट डिटरमाइन करेन की म्हणजे एक लाईन ड्रॉ करेन. एक लाईन अशी ड्रॉ करेन अशी लाईन ड्रॉ करेन की त्या लाईन मधून आणि माझ्या डेटा पॉइंट मधून जे काय माझं व्हर्टिकल डिस्टन्स जे आहे, ज्याला आपण इन टर्म्स ऑफ डेटा सायन्स दिस इज कॉल्ड एज रेसिड्युअल. सो रेसिड्युअल शुड बी अ मिनिमम. ओके, म्हणजे माझ्याकडे जी काय माझी लाईन मी ड्रॉ करणार आहे त्या सगळ्यांच्या मधोमध ऑल द डेटा पॉइंटच्या मध्ये त्याच्यापासून आणि त्या पॉइंट जर लिनियर डिस्टन्स जर काढलं तर ते नेहमी मिनिमम यावं. सो हिअर वी आर टॉकिंग अबाउट द व्हर्टिकल डिस्टन्स, नॉट एनी मिनिमम डिस्टन्स एक्सेट्रा. म्हणजे असं नाही की ते इकडून किंवा इकडून कनेक्ट करायचं आणि मग मिनिमम काढायचं. नो, हिअर वी आर टॉकिंग अबाउट द डेरिवेशन फ्रॉम द लाईन. ओके, म्हणजे या लाईन पासून हा किती लांब आहे हे मी कॅल्क्युलेट करेन. आणि यू in terms of values, when we talk about this, so here I can say that if I'm talking this about as a y, so I can say that consider this is a y, this is y in increasing direction and this is x into the increasing direction. Then At this point, I'm having different value of the y. Consider -2 or +2, or consider, let us say, this is a 4 value and this is a 5 value. So here I can have difference of 1. Now when I am talking about this difference with respect to this value, I can say that this is a 4.5 and 3.5. Again I will have difference of -1. Okay, so I wanted to have the minimize of this distance. मला तो distance minimize करायचा, भले तो positive असू दे किंवा negative असू दे. And for this purpose it will take a absolute value. मग त्या केस मध्ये हा त्याची absolute value घेईल. Absolute value म्हणजे काय आहे की 3 असेल तर 3, -3 असेल तरी सुद्धा 3, and that's why it will take a least square. Okay, ह्या absolute distance चा square घेतला जातो and later on it will find out the least square root. Okay, मग त्याचा square root घेतला जातो. So and for this purpose then it will go for the designing this model. मग ज्या ज्या कुठल्या लाईन मी ड्रॉ केलेल्या आहेत, सो हिअर whenever I'm talking about this, it is not mandatory that I should have, म्हणजे फक्त या सगळ्यांमधून एकच लाईन जाते असं नाही. ओके, फॉर एक्झाम्पल so here I can have line in this way, I can have line in this way as well, I can have this line as well. So here linear model ज्यावेळेस मी डिझाईन करते, या दोन्हींमध्ये कुणाचा स्क्वेअर डिफरन्स किंवा रेसिड्युअल मिनिमम येतो, दॅट विल बी माय मॉडेल फॉर दिस डेटा व्हॅल्यूज. म्हणजे समजा की मी ही जर लाईन डिसाइड केली तर फर्स्ट वन दॅट इज दिस वन. ओके, okay, I got 3 lines, 1, 2, and 3. So here, out of these 3 lines, if I'm predicting these 3 lines, then I wanted to find out the line which will have a least square root of the distances. म्हणजे हा जो माझा सम येईल या डिस्टन्सेस मधला, तो ज्याचा मिनिमम असेल, that will be my final relation linear regression model. Okay, so clear with this? कळालं का लिनियर रिग्रेशन म्हणजे काय? Okay, so this data points, this is another set. Then again we wanted to find out the minimum distance, minimum square. That's why this is linear model. So linear model, linear regression is having multiple variations. When we talk about in general, this is the ordinary least square. Okay, ordinary least square म्हणजे काय? The same technique which I explained. Square least square, it means that जिथं कुठे difference square minimum येतो, that will be my linear model. So here linear regression is the simplest and most classic linear method for the regression. Linear regression finds the parameters w and b that minimize the mean squared error. Squared error म्हणजे काय की ज्यावेळेस मी 2 पॉइंट्स मधला म्हणजे याच्यामधला जे काय हे रेसिड्युअल म्हणून मी जे शो केलेला आहे, ऍक्च्युली मी ही व्हॅल्यू प्रेडिक्ट करते पण येताना ही येते व्हॅल्यू, मग ह्या दोन्हींमधला जो एरर आहे किंवा जो काही डिफरन्स आहे त्याचा स्क्वेअरचा जो रूट आहे, that should be the minimum one. And the same method says demands the same. So linear regression is the simplest and most classic linear method for the regression. Linear regression finds the parameters W and B that minimize mean squared error between predictions and the true regret targets Y on the training set. So mean squared error is the sum of the square differences between predictions and true values. So linear regression has no parameters, which is a benefit, but it also has no way to control the model complexity. So whenever we are talking about the parameters, so we can say W and B are the only parameters available. X and Z are the existing data values. And that's why here we cannot control much more this data model. And there is also a discrepancy between the performance on training set and tested sets. So always it will go for the overfitting. Okay, so it means that our conclusion is instead of going for the linear model, so it's better to go for the complex control models. Even though the models are complex, but still whatever the target and predicted value are there, or existing values we can say, so that should give the minimum error or minimum difference. So this is the formula. So here we are talking about the difference and square and sum of the squares. So linear regression works towards reducing the cost function, which is usually the mean squared error by the number of data points n. So here this is code for the linear model. Actually, this is taken from the book. So I will not explain. So it means we will not explain in much more detail. We will shortly go through this. So mglearn data set. So here we are taking the housing data set. That is some housing data set is there, and that we are referring to the study. So we pass X of train data, Y of train data, then X of test data and X of Y data. Test of Y data, and then we initially give the random state equal to 0, that is the initial value given. So then we try to fit whatever the values are there, because here X and Y हा जो काही माझा डेटा सेट आहे, म्हणजे माझ्याकडे भरपूर सारा डेटा असू शकतो. जस्ट लाईक वेन एव्हर आय एम टॉकिंग अबाउट द लाईन. ओके, समजा मी या लाईन बद्दल जर बोलत असेल तर यामध्ये जे जे काही डॉट्स आहेत ते सगळेचे सगळे माझे डेटा व्हॅल्यूज आहेत. For example, this can be data of the cells, this can be data of the prices, this can be data about the what you can say, actual data of cells, actual purchase of goods, or actual classification results, etc. So, and that's why yes, and because of this, so we wanted to give some value of X and Y. These are the already existing value. So simply we wanted to calculate the A and X, that is coefficient and another attribute. Then next, ridge regression. So ridge regression, this is also similar to the linear regression, whatever we have seen. So the formula it uses to make prediction is same one used for the that is ordinary linear regression. And the main thing is that it will also have, that is the whatever coefficients W are there. So here it might go for the overfitting. Okay, in case of ridge, we are much more focusing on the regularization. So ridge regression may go for the overfitting, and in ridge, though coefficient W are not chosen only to say that they predict well on the training data, but also fit an additional constraint. So we also want the magnitude of coefficient to be small as possible, and all entries of W should be close to the zero. Okay. So with along with the training data, if we go for the formula, then along with the test data also some relaxation is allowed. So regularization means explicitly restricting models to have overfitting. So the particular kind, uh, so this will be using a real to regularization. So here this is a formula for this or code for this. And this is a Python code for using this. So here there is one more parameter, that is alpha parameter. So you might be wondering what is meant by alpha parameter. So here whenever we are designing a model, we always make some assumptions. Okay, assumptions, and based on the assumptions we it means some values also get some value. For example, if we talk about some activity today or tomorrow, then we might wanted to check whether tomorrow it's raining or not. It means that here rain will be there, rain will not be there. That is the output. But for this purpose, today I need to give the weather report for today. Okay, then that will be acting as an input. So it means that here we can predict the output. And for this purpose, we can use a rich uh, a regression for that. Then based on X train and Y train. So here, in case of previous, we are using the least square. Okay, the least square the concept use केला होता. But in case of ridge, it will not use a ridge. Okay, याच्यामध्ये एखाद दुसरं पॅरामीटर मिस झालं तरी चालतं. Sorry, that is in the last. So, but here trainingचा score max लागतो, so that it will not have the overfitting. Okay, so this is for the today. So those friends who are attending online, please give your attendance or don't leave the meet. Let me take the attendance and then you can leave the meet. 2 to 3 minutes are remaining. Okay, I'm done with the taking attendance. You can leave them.